In this video, I am going to explain about the construction and working principle of transformer. So the transformer, which we can see in many electrical devices and we can use in our daily life and mainly in power plants. So the transformer is one of the electrical machine that do not have any moving parts. So which are used to reduce or increasing the voltage level. So these are the some of the real time examples what we are nowadays using in our daily lives. So right side is single phase transformer, then left side is three phase transformer. So the transformer is a static device which transform electrical energy from one circuit to another circuit without any electrical connection. So and it can transfer the power from one circuit to another circuit without changing its frequency. So the definition for the transformer is it is a static device which can transform the electrical energy from one circuit to another circuit without changing its frequency. The working principle of the single phase transformer is based on the Faraday's law of electromagnetic induction. So based on the supply, the transformer normally classified as single phase transformer and three phase transformer. Next we can discuss the construction. So in any transformer, it consists of three main parts. The first one is primary winding, and the second one is magnetic core, and the third one is secondary winding. So the primary winding, the winding that takes electrical power and it produce magnetic flux when it is connected to electrical source. And second one is the magnetic core. The main function of this magnetic core is that the magnetic flux produced by the primary winding, the flux is passes through a low reluctance path linked with the secondary winding, creating a closed magnetic circuit. And third one is secondary winding, this winding that provides the desired output voltage due to the mutual induction in the transformer. So here the left side it represents the schematic of single phase transformer, and the right side the symbol of transformer. So it have two windings, one is primary winding and secondary winding. In between it represents the iron core, that is magnetic core. So normally we are giving input supply to the primary winding, and this supply, that is current, is produce the magnetic flux. That flux is links with the magnetic core, it can induce the EMF in secondary. Okay, if the circuit gets closed, then current is passing through the secondary winding. So from this you can see the current, that is IP represent the primary current. Similarly VP represents primary voltage and NP is primary winding. Similarly in secondary side, where NS is number of windings in secondary, and IS is secondary current and VS is secondary voltage. So the construction of the transformer, so earlier we have discussed it have two windings. So that is one is primary and second one is secondary winding. So in the iron core, which is used to ensure the passage of magnetic flux inside the transformer, is not as a single piece of casting you can see here. So but it consists of very thin plates, it is stacked on top of each other and combined together. So the reason for doing this is it reduce hysteresis loss such that the efficiency can reach above 90%. So that is the main reason we are using this type of construction. So in order to better understanding and understanding of transformer, so we must first look into the Ampere's law. So according to Ampere's law, a magnetic field is formed around a conductor through which a certain amount of current is flowing through this conductor. So it has two poles, north and south poles. So when the voltage is applied to the primary winding, so the current is produced. This current is produce a magnetic flux. This flux is linked with magnetic core. So as soon as the primary winding is connected to single phase supply, so AC current is start flowing through it, and alternating flux is produced in the core by primary current, and alternative flux gets linked with the secondary winding through this core. So according to the Faraday's law of electromagnetic induction, this varying flux will induce voltage into the secondary winding. So this is the principle of operation. So in left side it represents the DC current, and the right sides we are giving the AC supply to the primary winding. So with in any transformer, the if you are giving the AC supply, so then only it will increase or decrease the voltage level. So with the transformer only the AC voltage is increased or decreased, but if you are giving DC supply, it cannot step up or step down, because when the DC supply, that is DC voltage, is applied to the input winding of the transformer, a magnetic field is formed again. However, there is, because the DC current means the constant current, since the direction and intensity of this field will not change, so there is no voltage induction in the output winding. So that is why we are normally we are preferring AC voltage to the transformer. So if you see here, the first one, the input supply is AC source, so we will get output voltage, it may be increasing or decreasing with respect to number of winding. Then second one, second diagram, in this we are giving DC source, so there is no induced voltage in the secondary side.